Greetings, everybody. Thank you for taking time out to participate in our Focus Day session here at Understanding Risk. We're very glad to have the opportunity to share our work on seasonal forecasts and including integrating seasonal forecast into decision making. We have three parts of the session that I will outline in a bit. But first, just a little bit of an introduction. A little bit of an introduction of who we are. So my name is Andrew Kruchkevich. I am a scientist working on disaster risk, various aspects of disaster risk, including forecasts and integrating forecasts into decision making. I am based at Columbia University at the Climate School. We are here in New York City. More specifically, I'm part of a group called the International Research Institute for Climate and Society, IRI. And this work is a collaborative effort along with the World Bank's Global Crisis Risk Platform. So here we're very fortunate to have Dr. Lindsay Jones from the World Bank Global Crisis Risk Platform to share and reflect on a little more detail of the motivation around this work and the potential of future next steps. And then also we'll be joined by my colleague, data scientist Agat Bushri, who has done a lot of the back-end, behind the scenes work on designing not only the forecasts, the integration of the forecast into decision making, but also the visualizations as well. So thank you. Welcome to our session, Making Seasonal Forecasts Useful for Decisions. We will have three parts to today's session. Part one, how to use seasonal forecasts. Part two, a prototype for country-level seasonal threat profiles. And then part three, discussions and next steps. In part one, we will reflect on questions such as, what are seasonal forecasts useful for? What are seasonal forecasts? What are they? What they are not? And what are some of the main challenges in translating seasonal forecasts into actionable information? That's when we'll run through some examples and also talk about the current situation and the current global seasonal forecast. Then part two, Agat will be talking about a prototype for country-level seasonal threat profiles. So this is presenting different scenarios developed in collaboration with the World Bank Global Crisis Risk Platform and IRI in developing these country-level risk profiles. So we'll be sharing some of our work that we've done, and also some thoughts about the direction that the work is going in. And then part three, Lindsay will be joining us to react and reflect and outline some of the work and really talk about why seasonal forecast information can be of value to a group like the World Bank and elsewhere. So jumping into part one, how to use seasonal forecasts. We thought it would be useful to start with a map that maybe some of you are familiar with, and likely some of you are not so familiar with. This map is shown here. It is a map of the world, and there's different colors on the map, just breaking it down at a very simple level. We see yellows and browns, we see greens and blues, and what do these colors signify? So anywhere where we see greens into blues, this map says that those areas are likely to see above normal rainfall. The deeper the greens and into the blues, the more abnormal this above average rainfall may be. Now, the yellows into the darker brown, these are areas that are just the opposite, areas where we are likely to see below average rainfall. This map is a forecast. This is not a snapshot of the current conditions. This is a forecast issued February 2021 for the period March, April, May. So why seasonal forecast? Why would somebody choose to look at this map in February when it was issued and say, what are the conditions likely to be in March, April, May? And there's various decisions across sectors where this could be useful. Agriculture, for example, energy, for example, transportation, also humanitarian decision making, and development. And that was one of the motivating factors of our interest in this work. There are sectors that are using seasonal forecasts. However, there's some that aren't necessarily using them and may um, perhaps should be, or at least thinking about what it means to use seasonal forecasts in decision making. But the second question here is maybe the most important one. If all seasonal forecasts are incorrect, how can they be useful? You may be thinking, Andrew, you're presenting these forecasts and saying that they are useful, and they are. However, a forecast does not need to be perfect in order for it to be useful. In fact, no forecast is perfect. And in that sense, these are incorrect representations of what may happen, at least for some areas. Some areas, this forecast will be right, but there will always be areas where the forecast is wrong. Does that mean they're not useful? We don't. We believe that this product is an example of how to use uncertain information, forecast information, to make better decisions. Seasonal forecasts can support humanitarian development sector actions if these constraints are acknowledged. So this is a centerpiece of the project that we're working on. What are these constraints, and how do we acknowledge them in order to develop a useful set of information for decision making? In some ways, we think about seasonal forecasting as including a set of tools, a toolkit perhaps. It's one way to think about it. On the left, we see a map that's showing greens and brown colors in different parts of the world. This map answers the question, when we have La Nina happening, where are we likely to see shifts? This is different than a forecast map where we're looking at the current period. But this map on the left is generated through historical knowledge of what happens when we see La Nina or El Nino. Hopefully, everyone in the audience is thinking, La Nina is, I've heard La Nina might be coming, or maybe it's here. We'll get into that in a bit. But I've heard in the past weeks talking about La Nina. And it would be really useful to understand where we might see more rainfall or less rainfall during this La Nina. This map on the left will allow you to get a sense of where over time, over the past decades, when we've seen La Nina, these are the shifts that we have seen in the atmosphere in different parts of the world. This is how climate has shifted during La Nina. And we also have monthly ranges in that map to talk about that speak to when we might see those shifts. Now, that's a product that looks back at historical data to get a sense of what might happen in the future. The bottom right product here is a snapshot of what are the forecasts on a global scale and what are the potential shifts in rainfall for this current season or upcoming season. Sometimes this map on the bottom right looks very similar to the map on the left. Sometimes it's very different. Sometimes it's slightly different. Now on the top right, this is the official probabilistic ENSO forecast. What is ENSO? ENSO is the word we use to describe El Nino and La Nina conditions. This map shows the likelihood of La Nina or El Nino or neutral conditions happening. And this is also part of our toolkit to understand what may happen in the future, especially what may happen in the next months ahead, in the next seasons ahead as well. This map in the blue shows the bars on the blue, the blue bars rather, show the probability of La Nina occurring given the months indicated on the x-axis. So NDJ stands for November, December, January, the season. And then we see the blue bar that goes up to approximately 96% probability of La Nina. Well, that's because we are in a La Nina, and that's saying for the period November, December, January, we are likely to continue seeing La Nina. As we move forward in time, so as we move to the right on the x-axis, we see some interesting patterns emerge here. We see the blue bar getting smaller, which indicates as we move forward in time, the likelihood of La Nina decreases. We see red bars grow, which indicates increased risk of El Nino, especially as we get into JJA, which stands for June, July, August. Now, that red bar La Nina, or the red bar of El Nino and the blue bar of La Nina for JJA are very similar. Does that mean one of those is likely to occur? Well, we actually see the gray bar there, which says neutral is the dominant phase of ENSO in terms of probability. So it's most likely to occur during June, July, and August of next year. However, these I don't want to run through. The intention of showing these different tools is not to talk about what it means to be an expert in interpreting all of these. However, it is to say we have different tools. And depending on what your decision-making context is, depending on what your sector is, depending on the amount of people, including the most vulnerable populations that might be influenced by your decision, depending on your tolerance to uncertainty, some of these tools might be more valuable than others. And it is important to think about that and be able to connect with, let's say, people who bridge the gap between science and practice to understand which of these is most appropriate for your use case. Now, let's move into what's happening now. Is La Nina happening? It's a good question. On the bottom right, we see a chart that shows many colored lines. On the x-axis, we see some letters that correspond to groups of months that we call seasons. We also see on the y-axis the Nino 3.4 SST anomaly. What does that mean? That is the way that we measure the conditions of the eastern equatorial Pacific surface. And when we are below zero in terms of sea surface temperatures in the eastern equatorial Pacific, that means we are in, well, that means we are below average if we're below zero. And once we reach a certain level of below average, that means we have reached a La Nina conditions. And as we see here, if you look, the first line to the right of the y-axis, it says observed, and we are approximately at negative 0.8. That is a cold La Nina-like condition. And the models, as you move to the right, show agreement, general agreement, in that La Nina conditions will continue, but then begin to moderate a bit as we move forward in December through January and February. What does that mean in terms of rainfall conditions? Well, the map on the left is a seasonal forecast issued in November. So this is the most recent seasonal forecast issued for December, January, February, for the next 3 months, for the next season. And we see some patterns here that are worth noting. For example, if we focus on Southeast Asia, we see very dark blue colors over the Philippines and into parts of Malaysia and Indonesia as well. This indicates an increased likelihood of above normal precipitation. If we look in East Asia, parts of South Korea, Japan, and China, we see yellows and browns. This indicates an increased likelihood of below normal precipitation. Now, are these La Nina impacts? Yes and no. There are many things going on in the atmosphere that might lead this map to indicate below or above normal rainfall. However, one of the typical impacts from La Nina is below average rainfall in some areas and above average rainfall in other areas. So again, these products help tell the story of what might happen in the next 3 months if we're interested in precipitation. And we definitely see some signals here that can be connected to La Nina. So some key messages. La Nina is indeed here, and this is not just a declaration from myself. It's a declaration from the US government. As you see in the top right, La Nina is present, which means equatorial sea surface temperatures are below average across the central and central Pacific Ocean. The bottom point there is La Nina is likely to continue to the northern hemisphere, or through the northern hemisphere winter, and into the spring of 2022. But then in the bottom right, we also see the recent declaration from the Australian Government Bureau of Meteorology saying that La Nina is underway. And this is important because we're seeing agreement from the different agencies on a global scale that are responsible for monitoring the conditions that mean La Nina. So the key message is La Nina is here. La Nina is influencing conditions globally. But there's also more questions to ask, which we are actively doing. Will this be a strong La Nina? Does a strong La Nina mean strong impacts? What are the expected La Nina impacts? And will we see all of the expected La Nina impacts? These are questions that we are discussing. But even as such, we have the data. We have these official declarations. But what can be done? What should be done? What is sufficient in terms of taking anticipatory action based on these shifts of risk? And these are questions that are important to ask, but much more difficult to integrate into policy development and into prioritization and deprioritization of specific countries and also sub-national areas of interest. So that was a little bit of a background of seasonal forecasts, talking a bit about La Nina and setting the stage, of one of the motivating factors of this work. And to elaborate a bit further, we will hand it over to Agathe, and she will speak about the prototype for country-level seasonal threat profiles that we've been working on with the Global Crisis Risk Platform. So over to you, Agathe. And also, please hold your questions for later. We will have time after this part to go through and address any questions. So please hold your questions in the chat. Okay, over to Agathe.
Hi all, I'm Agathe Buchery. I'm a research officer at Columbia University, working at IRI, so the International Research Institute for Climate and Society. Well, before starting, I wanted to apologize for not being able to be live with you today. But so yeah, in this section, part 2, we are going to see with concrete examples how to translate seasonal forecast information into country-level emerging threats profile. And we will discuss the different methods we explored and the main challenges that we think are important to consider. So first, with prototype 1.0, we will address some of the methodological challenges that we face with extracting critical signal from seasonal precipitation forecasts into a list of countries with emerging threats. So that's the output you see on the right. With prototype 1.1, we will explore more the importance of adding information about the persistence in dry conditions that are able to improve the confidence we have in our results. And finally, with prototype 1.2, we will discuss the importance of adding exposure dimensions, so exposure criteria in the methodology, such as population density and agriculture share. So first, using only precipitation seasonal forecast information as input, how best can we extract critical signals and translate that into country-level threats? So that's what we first explored. Every month, IRI is issuing a seasonal precipitation forecast for the next 3 months. And here we see on the map the February, March, April precipitation forecast issued in January 2021. So this forecast indicates for each pixel a probability to be above or below normal condition. And it's important also to note that we are talking about two different dimensions that will lead to a wet or a dry indicators. So how do we use these products? We have here discussed 2 points. First, we need to define which probability threshold is relevant to use to extract the pixel that have a critical signal. So we've been using only one single critical probability threshold for the dry and the wet indicator, and we conducted sensitivity analysis that concluded that a threshold of 50% was the most appropriate value and capturing enough signal for this exercise. So that was the first point. And the second point is once the probability threshold is defined, we then need to address what proportion of pixel below or above the threshold is needed to flag a country. And we can use either a single threshold or explore different threshold per country size. So that's how does that work with example. So that's what we are gonna see now. So here we are exploring two country proportion approach and results. So on the left, we see a single country proportion of 50% as a method, and on the right, we are using different proportion threshold depending on country size. So country are classified into 5 classes of size, allowing for large country to be flagged only if 10% of the country, for instance, has a critical signal. And we can restrict also very small countries to be selected, for instance, only if all pixels show critical signals. Then on the top, the two maps, they show the flag country outputs using these two different approaches based on the February, March, April forecast. And on the bottom, this figure, they indicate that for 12 consecutive issued forecasts, the proportion of flag countries per class of country size. So small country like class 1, and large countries are indicated as class 5. So as a conclusion from this slide, we see that while the number of countries picked by the two methods are similar, the outputs are quite different. And if we use only a single country proportion, this created a bias toward flagging most small countries. So this shows that the importance to implement different proportion threshold per country size. So the method on the right, and it results in a better distribution of country flagged across country, across country class size. So we are now going to look at the potential integration of the persistence in dry or wet condition in the methodology. So information about the persistence in dry or wet condition are very important to identify countries with emerging threats, and it can help identifying, for instance, where are we likely to continue to see drier condition than average, for instance. So to do so, we combined precipitation observation of the most recent 3 months with the next 3 months precipitation forecast. And you see on the map on the left, for instance, areas in orange are showing past dry condition and a likelihood of more than 50% to continue to be drier than normal in the next 3 months. So by adding also observation data in our approach, we now also increases the confidence we have in our outcome. So it was integrating the persistence of dry condition that has improved most our results. So here we can compare the results from the prototype 1.0 on the top using precipitation forecast only with the results from prototype 1.1 at the bottom that is integrating the continuity in a dry condition. The map you see on the right, they show the flag country outputs from these two prototypes based on the February, March, April forecast. And the histograms that you see on the left, they indicate for 12 consecutive issued forecasts, the total number of flag countries in blue, as well as the dry indicators only in yellow and the wet indicator only in red. And as a result, so we see a slightly higher number of countries that are flagged with prototype 1.1, but this integration of the persistence in a dry condition, they lead to a more even number of flag country in the wet and in the dry category, and that was really an improvement. So finally, we're also addressing with prototype 1.2 the importance to integrate the exposure of any valuable assets within the country level threat profile method. So we are going to look at only the exposure of population and agricultural assets. In these slides, we want to make sure that critical precipitation signals that are identified in areas with low exposure, this should not trigger a threat alert. So to do so, we generated a low exposure layer that you see in the bottom using the CZIN GPW population density layers seen on the top left, combined with Earthstat cropland and pasture share data on the top right. So this low exposure layer is now used as a filter, so to filter out any low exposure areas in the process of generating a country level threat profile. So finally, here it's a summary of the prototype 1.2 methodological step from the precipitation forecast to the flagged country results. And it's all based on the data available in January 2021 for the February, March, April period. So on the top left, you see the IRI multimodal probability forecast for precipitation. On the top right, it's the critical signal that we extracted from precipitation forecast anomaly, so in red and blue, and also from the persistent in dry condition that you see in orange. The bottom left is the low exposure area filter that we saw, and bottom right are the resulting map, flagging this time 36 countries with emerging threats. So after performing sensitivity analysis on also several issued forecasts, we realized that prototype 1.2 show promising results that are related to the critical precipitation signal that we extract, that we are happy with. Also the final number of country flag that we feel adequate, and we also see a good balance between the wet and dry country indicators. But obviously more could be explored to improve this prototype. But now I will let my colleague answer your question on this methodology, and also continuing discussing next step and the application of this work. Thank you.
Thank you so much. Agat, for sharing the process and the methodologies. If I could share screen, we could move on to the next part of the talk, of the session. Let's see. Okay. I believe yes. Lindsay, can you see my screen?
I can.
Great. So thanks Agat, so much for that. And next we invite Lindsay to share some thoughts, reactions from that, and contextualize what we've been sharing so far in the session. Over to you, Lindsay.
Thank you, Andrew. Yeah, and thanks for a great presentation from Agat there. I won't take up too much time. I know there's a lot of people waiting to ask questions, so I'll try and keep this as brief as I can. But as my role, I guess, as a discussant, as someone sitting in the World Bank, in the Global Crisis Risk Platform, I guess I have a few high-level thoughts that that relate to some of the work that was described here, but also thinking a bit more broadly about what we need to do as a community of practice working in both development and humanitarian sectors to make seasonal forecasts more actionable and more relevant to the types of decision makers that I kind of sit in my world, right? And this is mainly regional and national level decision makers. So I guess a few kind of high level thoughts to speak to that. And I've got 3 points that I think I'd like to get across. I don't know, Andrew, if you can go to the next slide, just to kind of give it that contextual bit, because it relates to this work that Agat was just presenting, moving from the raw seasonal outputs, which you can see on the top left-hand side, through a series of layers, all the way through to something that national and regional decision makers actually are much more comfortable with in terms of simple communication of where risks might be. And that's what you see in the bottom right-hand side. So I guess the 3 main points, I guess I would start with point 1, is that seasonal forecasts really do have potential to guide and inform development and humanitarian decision making. Right, there's a considerable amount of potential for that 2 to 6 month time horizon because it covers a critical window needed to support anticipatory decision making. It really is an important kind of element in thinking about pre-positioning of technical and financial resources. Right, that time period, is one where you really can act in advance. You can support, crisis preparedness. You can support anticipatory action in ways that you can't, with other types of climate information and weather information. And the bit that I guess is unique to seasonal forecasting is that it unites both development and humanitarian communities. Right, that's unlike weather forecasting, where the time horizons are too short for development communities. Weather forecasts, can be very useful for humanitarians. They can give you, very quick sense as to what's coming up in the days, up to 10 days or so into the future with relatively high accuracy now. But it's of very little relevance to the places, where I currently work. For example, in the World Bank, our operational timescales are much longer term, right? So that time period doesn't really fit for us. The inverse is true for things like climate forecasts, right? Climate projections. So we have multi-decadal projections that are of use to places like the World Bank and other development organizations, where we think more along 5, 10, 15, and beyond in terms of your timescales. And then I guess when we think about the inverse, right, for humanitarians, that multi-decadal time period is less relevant for their operations. So this is where we see a kind of a nice uniting, bridging point, as seasonal forecast being, probably the sole, timescale for climate information where we have both interests, from both parties. It might not be the primary time period of interest for both, but it is nonetheless something that unifies them in being able to act on that, which is unique. Second point is that despite that potential, despite the strong ability to be able to use seasonal forecasts in decision making, seasonal forecasts actually are very rarely used in national and regional level decision making. Kind of the big decision making agendas that we see within large development organizations, and also at country level kind of national political agendas. We very rarely see that information being taken up, and it's a shame because it really can inform important and relevant decisions that get taken at that level. There's a number of reasons for that, I think. One reason is that seasonal forecasts are already tailored to national and regional decision-making environments. right? So, the way that seasonal forecasts now are presented or commonly are issued, they work for local actors like the Red Cross, but for places like the World Bank, they're less necessarily tailored and relevant. We normally see them in relation to high spatial resolution outputs, right? So we have, 25-kilometer grid cells or so where we see the forecast coming out, similar to what you see in the top left-hand side. But what we don't really, what we rarely do get is an aggregation of that information at the regional or the national level. While there obviously are many uncertainties and limitations in doing that, it's actually a decision-making scale where a lot of the important decisions do get made. So the fact that we're not speaking to it and presenting simple country-level tailored information related to the seasonal forecast is actually hindering, key decision makers, ones that maybe don't traditionally use seasonal forecast or even climate information in their decision making. It hinders the ability for us to be able to communicate that information to them directly. The more important thing actually is that forecasts, currently the seasonal forecasts very rarely include outside factors like exposure and underlying drivers of vulnerability. This is a key part of what Agath, the work that Agath and Andrew are doing together with us on, right? The fact that we not only need to show what the forecasts say, we need to know if that forecast is affecting areas where there is potential for high exposure to, particular assets, or where there are there's a high likelihood of vulnerable communities or assets or resources in that area being affected by whatever is being forecast. So that's really, really vulnerable. Really, really important in part because in most cases, to make those decisions, we need that information to be there and to be present. It's all well and good forecasting, extreme drought or extreme, levels of precipitation for an area where there are no people and there are no assets. But actually, when we take that to a decision maker, that means almost nothing. What we really want to know is that area, where we're seeing an anomaly from the seasonal forecast, is it one where we have, high levels of people exposed, where potentially there's some agricultural land or land that's being used for pastoralists. So that's really important, and that needs to be included with that. The overlaying of that data doesn't inherently need to be complex. And that's part, again, of what the work that we're doing here is showcasing. It can be built around simple flagging systems. As long as that methodology is transparent and communicated effectively, there's no harm in coming up with something that does try to combine it without trying to make it overly complex. I guess the third and final point that I would make is that, as part of the GCRP, the Global Crisis Risk Platform at the bank, and others, we really want to be pushing for a new generation of risk products to explicitly target different levels and different scales of decision making. So at the moment, obviously, seasonal forecasts are tailored for particular environments, right? They often get disseminated and used by meteorological services, local organizations like the Red Cross and others, and they are targeted towards those. What we don't necessarily see them targeted towards are higher level decision makers, right? So ones at the national regional level, places like the Ministry of Finance, places where, like in the World Bank, where we make decisions based on different timescales and based on different scales of operational activities. So in order to do that, in a way, we need to be able to do a few things. We need to be able to combine that seasonal risk information with wider country level risk information, right? The other thing I guess that's important to mention here is that we're not only interested in seasonal risks, we're interested in the way that seasonal risks will compound and interact with other drivers of risk, right? So that could be macroeconomic instabilities, conflicts, food insecurity, health, with COVID ongoing at the moment. So it's all well and good presenting this information, as a standalone. But really, for a decision maker at that kind of a level, for a national or regional level decision maker, they also need to be able to know and combine that information from the seasonal forecast with other pieces of information. That makes it tricky. Obviously, there are interactions across all of them. It's very hard to model. But like we said, that overlaying of the data and that information doesn't inherently need to be overly complex. We can communicate that in ways where we essentially where we can present, countries where there are multiple thresholds that are crossed, where there are multiple drivers or trends, pointing to, heightened or exacerbated risk that we should be flagging. I guess all of this is pointing towards, instead of trying to be exact about some of these forecasts in terms of those interactions, which we can't do, let's move towards being, having systems that are simple, transparent, and can point to areas where we need to be vigilant, pointing to decision makers to put things on their maps and their radars. This is why within the GCRP ourselves, we're developing what we call the compound risk monitor. So this work that Agatha and Andrew have presented, that feeds into part of it. It's essentially an early warning system that tracks compound risk at the country level. So it's a global system, but it goes down to essentially country level inputs. And it identifies, or it tries to identify countries where there are more than one type of risk, that's above a particular threshold and that has the chance to result in a compound crisis. And the outlook for that is 3 to 12 months. So again, something where the seasonal forecast can be very informative of. I think more broadly, our aim as a risk management community, though, should be to try and identify and be better at identifying simple and intuitive ways of communicating risk, making sure that they are tailored to decision-making environments where we can act, where there are high-level, champions of change, whether that be in places, like the World Bank, whether that's in places like the Ministry of Finance, Ministry of National Planning, where traditionally things like the seasonal forecast hasn't been advertised towards. And if we do that, we need to think about different ways of communicating that information, simpler, easier to communicate, a bit more transparent, and doing so in a way that is tailored towards their decision-making environments. As I mentioned, this doesn't necessarily need to be something where we worry too much about the uncertainties, because all we're doing is flagging areas where we think there needs to be extra vigilance, not projecting the exact timing or the extent of a future crisis. So that's important to make, point to make. Last couple of things. I think the efforts like these, the efforts like the one that we're talking about through the presentation here, can really enable development partners, like the bank and the places where I work, to support anticipatory action, something that we've been struggling with thinking about how to do, because it's not an area that development partners, which typically have longer timescales, can act on. We're not humanitarian in that sense of having very responsive and quick to act structures in place. They're actually very difficult to get up and move, depending on new pieces of risk information that we receive. So we need to be finding the right ways to feed that information in and finding the right people to target. I hope that this work is able to spur on further efforts to think about how we integrate seasonal risk, with wider exposure and vulnerability data. More importantly, I hope that it's a way of helping us think about better ways of communicating and understanding compound risks, how we can act on those, bring together national, regional level decision makers, and start thinking about better ways of visualizing and communicating that risk data. So I'm excited about this kind of work. I'm excited to see what it leads to in the future, and I hope that others will take inspiration from this, borrow from it, and start thinking along the same lines, or all in the hope of trying to bridge these various communities between the humanitarian, the development, and scaling things up from granular, high resolution data that we get on the left hand side to the summarized, more comprehensive overlay data that we see in the bottom right hand side. So I'll leave it at that. Over and back to you, Andrew, for your final and closing remarks.
Thank you, Lindsay. I think I'll leave it on this slide because I do think it represents not only where we started, in terms of the top left, but demonstrates the direction that we're moving into. And a couple of key words from Agathe and yourself I would like to highlight. Accountability, opportunity, and in decision making. And I know there are simple words, but thinking about what each of them mean and how they could be present in communicating risk. So on one hand, this presentation, as Lindsay said, one intention is that it inspires and motivates others to build off this. But in terms of communication, it's definitely a call to action, let's say, for others that are exploring that aspect of the risk community. How do we communicate this complex overlaying process or processes in a way that maintains transparency, is rigorous and respects the science, the constraints of the science, but also leads to decisions to be made and action to be taken. And these are questions that remain open. We hope that this, again, motivates people to explore in different ways. We are open to feedback and discussion, very much so, and thinking about where to go, how to build off this. So yeah, definitely, it's a opening the door here for participants and also others in the risk community across science, policy, and practice for us to come together and think about as we develop compound risk monitoring processes and financial instruments and forecasting techniques relative to compound risks and in concurrent extreme weather events. How do we do so in a way that builds off the forecast work that has been done, focuses on the most vulnerable populations, but also leads us to develop sustainable processes that can be applied to different areas on a global scale to respect the interconnectivity that the disasters have with one another and also across sectors. So I think we'll leave it there for now. Lindsay, what do you think about closing the session? Any final reactions on your end, or any thoughts on the questions from the participants?
No, thanks, Andrew. I think we're good here, and I'm very heartened to see that so many people, also agree with the importance of this subject. As I said, I'm really excited that that this work is being done together with yourselves at IRI. I think there's a lot of potential. I do believe that instead of trying to get too bogged down on the specifics, on the complexities of interactions between exposure and underlying vulnerability, that we also do need to find ways forward that communicate simple information, simple, actionable risk information that doesn't, whether we don't scare away from producing that, but at the same time make sure it's, like you said, transparent, that it's robust, and that we get towards a position where we can share this information to people that don't usually receive this.
Yeah.
So I'm looking forward to exploring some of those ideas together with yourselves, together with others in this community. And I'm very excited that we can kick off this session, present some of this information, and looking forward to seeing what comes out of it in the months and the years ahead.
Definitely, yes. And in closing, specifically in the Asia region, many opportunities to focus on the region and build off many of the other activities and align potentially with many of the activities to ensure clear, simple, yet effective and sustainable communication of these risks. Thank you all very much for participating, and please reach out to Lindsay and or myself with any additional questions. We're very happy to have further discussion. Thank you all very much, and we wish you a very good day.
Thank you.